as he mentioned, co-working is one of my interests, also embedded microprocessors, wearables, at FabLab, 3D printing, laser cutting, and then also robotics and AI. I'm an amateur, but I say that proud. I'm an amateur because if you look at the word from French, I love what I do. So before we start, let's do a little reality check, which is also interesting. Who of you knows the matrix? What if it's a documentary? And I don't mean the human battery part. I mean the other part. So ask yourself the question: how do you choose to see the world? Because at the end, it's your consciousness that forms your reality. So you choose how to see your world and your reality, similar to as in Matrix. And life actually happens from the inside, from you to the outside, not the other way around, which is quite interesting. Just wanted to put that in. So if you want to achieve something, then it comes out of you, from the inside. And you can create it. Which brings us to the next topic. I want to start a bit general. Humans create. We came to this world, we had 2 hands. The first humans had 2 hands, but they built everything by hand with their bare 2 hands. As you see here, if you go out into the woods with pans and 2 hands, then you can start to build your tools, and from them you can build up more tools and go on and go on. And the last few thousand years that we were on this earth, you saw this happening. We now have different tools, of course, which brings us closely more into the topic I want to talk about. How does this all happen, that we have our hands and know what to do with them? It's all about a creative mindset. We are very creative. If I sit down, if I have some hardware and some software, I get creative, and then fun stuff happens. And then we come to the topic of technology, as we are in a technology conference. Technology is an enabler, and it's a huge enabler, as you can see in the last years what we all have created. So one of those technologies is JavaScript, and actually the whole web ecosystem, as you are all familiar with. And then we come to robots. Now, you might say, robots and JavaScript, really? But go back to 2009. Who recognized this guy, this unknown guy? Called Ryan Dahl. And he said, JavaScript and server, really? But he said, it's possible. And now, all the years later, we know that it's actually a good idea. Node.js. He's the creator of Node.js. So, Node.js solved everything around non-blocking I/O. And if we talk about robots, which are hardware, all the hardware is also blocking I/O. So there is a really good fit to use JavaScript and robots, or machines in general. For example, if in Node.js you want to watch files being added to your file system, you do it like that, the upper example. In the old way, you just looked every second or every 500 milliseconds and see, is the file here or not? Not a good idea. And it's blocking. This is non-blocking. Same thing happens with a robot that has sensors. Let's say I have a robot that has a distance sensor in the front. Do I want to loop around and ask every 2 milliseconds, is something in front of me because I have to stop early enough? Probably not a good idea. So I code it like that and say, if the proximity changes, only then I do something. So, as you can see, robots and JavaScript are a great match. Plus, of course, the familiarity. It's one of the most used language by now. The huge community around it, and it's deeply rooted in the open source world. So again, people create, share, and then everyone builds on each other's tools and makes them better. So, which brings us to the topic of AI. Some people might say, hey, all our jobs will be gone. Or maybe some people might even say, at the end, some robots will kill us all. I hope not. But ask yourself, what do you think? And if you're more into the tech world and know more the details, then you probably know the answer that it's neither. Because AI is not a black box, or even black magic. It's something tech, and actually not only tech. AI is deeply rooted in biology. So we are AI too. Maybe not artificial, yeah, who knows? If someone else is running us as an experiment in the matrix, then maybe we are also AI to them, who knows? So AI takes the concept of neurons that we all have, that all living things have, and as biomechanical machines that can compute. And they form neural networks. So as we saw, each one of them has different connections, and they all connect together, and then you form networks, and that enables them to do more complex functions. So AI, one of the topics, AI itself is a big field. I'm going to concentrate on one topic called reinforced learning, especially together with this robot. And again, this is actually interesting together with psychology, because reinforced learning is all about reward and punishment. You probably know well, or if you have kids, then you know it very well, how that works. So it's in reinforced learning, you have an agent that moves in an environment. So in this case, it would be this robot goes around, walks, drives around in the environment, and then collects something, collects reward, and then based on the reward or punishment, learns to do better. And we all know that from psychology. Also interesting in that field of reinforced learning are genetic algorithms, which are, again, rooted in biology, survival of the fittest. Because this robot is learning, at the beginning it doesn't do well, but you choose a lot of robots that do the same, and then you select the best ones that did the best, that collected the most reward, and then you go into the next round. And all the ones that didn't collect much reward will go away. So the goal was to build a light-seeking MOTH, because they also have one of the basic functions of that living object is to go towards the light. How can you build that? So it's basically a robot with two wheels to drive around, and then it has light sensors that collect light, and there they are arranged on the robot. Say, I have one in the front, one in the back, one left, and one right. That way, the robot can figure out, depending which sensor gets how much light, which direction to drive. But will not program it, it will actually learn it. For training, we could actually build 1,000 robots and then train them. Would probably take a while and it would be very uninteresting to watch that. So instead, the robots are trained, their network, their neural network, is trained in software. So here, Unity was used. It's usually or mostly used for games. It has a physical model of a robot with 2 motors and sensors. And then as you can see here, it has a grid of 100 robots. And then it will initialize the neural network of all of them with values, and then try out where does it drive to and how much reward does it collect, how much light does it collect. So at the beginning, if you start to train, they don't know anything at all. Their neural network is uninitialized, so they just drive around some. But some of them will actually drive towards the light and collect light and have a reward. And then, as I mentioned before, we have the genetic algorithm. It will then select the 50 ones that have collected the most reward, light, and go into the next round. And then do that over and over again at the end. With this one, we saw you have to wait between 1 and 2 hours, depending on the speed of your machine, and between 100 and 150 generations of training. And in each generation, it's 1,000 robots that are trained. And then you see, starting to see a good behavior that the robot actually moves quite reliably into the light. So we have trained the network. Now we saw that before. Here I can tell you what this means in terms of this robot. The input layer are the 4 sensors that collect light. And then the 2 hidden layers are the computation itself. And then the output layer are just 2 neurons that talk to the motors and tell them how to drive. Then we actually built the robot, as you can see here. And as I work in the Fab Lab, I can actually build a lot of it myself. For example, those parts are made on the laser cutter out of wood. Some parts here are made on the 3D printer. And some parts are bought in the store. Microprocessors, motor controller. So you can choose the design. And in around 1.5 hours, you can build your own robot that drives around. Then the interesting part is the brain, the artificial brain. How do you do that? The brain software, so to speak, is JavaScript. How does that all work? How do you link JavaScript and hardware? You usually have a microcontroller, and those talk to the outside world to program with serial. So if you're old like me, then you probably remember modems that used to be hooked up by the serial port. That was ages ago. These days, this serial is only used with USB. No more serial ports. So the microcontroller, then the serial port on the microcontroller, and then USB. And then there is this module, Node module for Node.js called Node Serial Port. So the data from the serial port from the microcontroller flows into Node.js, and then you have communication between hardware and software, hardware and JavaScript. Of course, you don't always want to use a cable for your robot. So these days, you usually use Wi-Fi or also Bluetooth. Works the same way because on both serial is used, it's just piped through Wi-Fi or through Bluetooth. But at the end, it works the same way. And also, there are some node modules that abstract away which transport is used. What you also need, or it makes sense to use a framework. Also, if you're older, you might remember that movie, Johnny 5. I think it was the 80s, probably, ages ago. So this is a robotics framework for JavaScript, for Node.js. It abstracts away much of the complexity. For example, if you want to drive a motor or talk to sensors. Then what hardware do you use? Can you use? BeagleBone, Raspberry Pi is probably familiar with many. There are also combinations between Arduinos and Raspberry Pis called PCduino or ESP processors, which integrate Wi-Fi directly, which are really powerful these days. Tesla 2 is also a good one, and they run Node.js directly on the microprocessor. This is also interesting. But of course, Arduino, which is by now quite established, or the particle boards, and they're actually thin clients. So they're connected to a host, cable, Wi-Fi, Bluetooth, and then Node.js runs on the host and then sends the commands to the microcontroller, because those are usually microcontrollers that don't have that much power. For example, an Arduino is still 8-bit, 12 megahertz. So don't know how much. It probably has 2 kilobytes of RAM. Hard to imagine if you're used to something like that. So Hello World, of course, is also used in the world of hardware. This is an example of a Hello World with Johnny 5. And it's quite interesting. You only need a few lines. You define a Johnny 5, of course, a board, an instance of the microcontroller, and an abstraction. And then as soon as the board is ready, initialized, then you define an instance of an LED. The only thing you have to tell is this number 13. This is actually the pin on the microcontroller board. Where is this LED connected? And then all you have to do is LED.blink. And then it blinks on and off every second. So a few lines. And you also see how much abstraction there is in frameworks like Johnny 5. That's your result of Hello World. So now we want to move the neural network into JavaScript. A trained neural network is actually quite easy in any language. It computes every value for every neuron through all the connections and then the output. So even this tiny microprocessor with 12 megahertz can do that without any problem. The interesting thing is actually transferring the training data, as we saw before. I just spent 2 hours on my high-power MacBook to train the neural network. That took the most time. You couldn't probably not do that on a little microprocessor. And what you calculate there are all the weights of the neurons. And then you only have to transfer those. Those are usually in arrays. We see here we have 4 input nodes. Those are the 4 sensors. 10 hidden nodes. And 2 output nodes. As I mentioned, those are the motors. And then for all of them, after training, you have all the weights, all the values stored, and then you have to transfer that. And that, together with Johnny 5 to drive the motor, you now have a neural network in JavaScript. And this robot, which you can then take a torch and have it drive around, because it was trained to always follow the light. So, this is the first and easy example. What can be next? For example, I can switch to a Raspberry Pi, which are quite small and would fit on top here, and a camera. Since I'm using JavaScript and a JavaScript framework, it doesn't matter if I use an Arduino or a Raspberry Pi, the software is still the same. I could attach a camera, start to work with image recognition. TensorFlow is also in JavaScript. I could also work with that. Or if I use, as I mentioned before, the host running Node.js and just sending the commands to the robot, I could also run a lot of the software on the PC, communicating with the cloud even, and then just send the results to the robot that would then drive. That's also a possibility. I hope it's also interesting to have pre-recorded, pre-trained training data in the cloud, and then the robot would pull that through Wi-Fi to the robot and then drive around. Those are some of the ideas I'm working on. So now the question, now you have some background. The question is, what will you build? And I'm looking forward to hear what you build. That's it. Thank you very much. So now we have enough time I can take questions before we head to lunch. Any questions? Yeah, I'll after lunch I'll go to the side tables and then show it off a bit.
So are you using this as a teaching tool for people that are not familiar with robotics?
At the moment, yeah, that's one of, besides being a hobby project, it's also used in workshops. So either for kids, I'm starting to find out where is the age where you can introduce AI into the classroom, which will be really interesting. I think it will be around 12. I think it's good if AI comes into the classroom that early, especially if they can really grasp it, if it's used as software, but also hardware. And I'm also using it in workshops for managers, because or non-technical people in general, because there the same thing happens. They hear a lot about AI and what it can do, but they also hear a lot about, like what I said in the beginning, killing us all or eating all away our jobs. But then again, if they have the software and hardware, and in the workshop they actually build this robot and then have it drive around. So they have learned theory, the implementation, the training of AI, and then they have an actual object that implements AI. That works very well. We found out that non-technical people really understand and grasp what AI is. Any other questions?
Sorry, there is a Node-RED. What is the difference between Node-RED and Node.js?
Node-RED, as I have looked at it too, it's more used for workflows.
Okay.
So there you can say, I take data from there, add it to a database, then pull it back, and then send it out there. So it's, yeah, I would describe it as a workflow tool. It runs on Node.js in JavaScript, but no other connections besides the name.
Yeah, we still have time actually, so.
Yeah, we have time. And you can also grab me at lunch and afterwards at the side tables when you can see the robot in action, which is interesting.
How powerful is JavaScript compared to things like C++ or Python for programming a robot?
For me, it's actually, I'm probably biased because I use JavaScript that much. For me, it's powerful enough. So you can do everything. I never came to the limits to say I have to use another language to be fast enough. Let's say that. It's fast and it's very reactive Also in robot environment where you have lots of sensors and a lot of data flowing, it works well. But it also helps that the microprocessors that we are using now, like a Raspberry Pi, has 4 cores and 1.2 or 4 gigahertz. Just as an example. Or the ESP32, which is quite new, implements Wi-Fi, is $7 probably, and has dual cores and 240 megahertz. So as you can see, the progression of hardware is fast enough that you will probably never hit the limit, even if you're using an interpreted language like JavaScript or Python. So yeah. And if you're using JavaScript, you just have in my opinion, it's way easier, a lower barrier of entry.
Are we good? One more.
For your robot, what do you put as a reward and punishments? Can you explain a little bit on that? Like when you say you have, so in deep reinforcement learning,
Right.
you define some rewards and punishments
Exactly.
for
Yeah.
the algorithms.
Yeah. So in this implementation, the reward is the result of all light sensors. So each light sensor collects an amount of light, and it's a value at the end, a number, and then all those are added up, and that's the reward. And in the reinforced learning, in the training phase, I look at all the robots that have a higher total number of light. So which robot has collected as much light as possible. That's the reward. And there's actually a punishment. It's interesting because, especially with this robot, this can turn very fast around. So we saw in training, one of the interesting things is if the light is above the robot and the robot just turns in circles, then it collects the most light, but it doesn't do anything. So a punishment was added to the training to say, the more you turn angular, the more punishment you get. And then you have to use that as an optimization method. Otherwise, you'll end up with robots that just go in circles and are happy, yeah, I have enough light. Which would be another optimization. Hey, I'm a lazy robot.
Okay, I think we wrapped it up. Thank you so much, Markus, for this. And so, I'm trying to figure out if this is your gift or this is your gift. Did you get some chocolate? That means someone forgot their chocolate. Maybe you get 2, maybe not. Let me try to figure this out, Zach. Because then, there might be some logistical problems. So please welcome, please applaud him once more for his very interesting talk.